Hello friends, welcome back to my channel. In this video, we are going to look at a full project. Now this is going to be a step-by-step guide on how to deploy a Node.js application. Okay, so we are going to look at how to containerize a Node.js app and deploy it using dockercompose. This is a good project for beginners in DevOps and IT. Stick around for the entire project. This is an overview of how the project is going to be. We have a Node.js application here with the source code, some specifications. Then we have package.json, yarn.log, and then a readme file. I'll provide the code in our GitHub repository so that you can download it and use it on your own. What we are going to do is to build an artifact out of this Node.js code, which is a Docker image. So to build a Docker image out of a code, we need to write a Docker file. And then we use the Docker file to build the image. Now once we've built the image, we will then go on to run that image that we've built to see if it actually works. When you start running the image, then it becomes a Docker container. That would be the first part of the project. Now for the second part of the project, we will attach a MySQL database to our container image. One thing that you will learn is that the application takes some input from the user. Now, if an application takes an input from a user, whatever information that the application is collecting has to be saved. Very early on, you will learn that when you stop the container and restart it, any information that you feed it is lost. So you need to find a way of saving that information. And so that will lead to the part 2 of the project, which is adding a backend database. This is also going to be a Docker image that we will pull from Docker Hub. Then we will attach it to the container of the actual application so that every data that is put in there by a user is saved to the database. For our deployment, we use dockercompose to deploy it onto our local host on port 3000. And of course, every stage of this project, we will be doing testing and verification to be sure that everything is working correctly. I'm going to give you a slight review. So here are the parts that we are going to look at. For part 1, for part 2, for part 3, and then to conclude, thank you for being here. Stick around for the entire project in all 3 parts. Hello friends, welcome back to my channel. If you've seen the review of our projects, today we are going to look at the first part, which is where we will containerize our application into a Docker image. So a few things to take note of. We're going to create a Docker file, and I'll use a Node 18 Alpine base image. Then we'll create a working directory, copy project files, install dependencies, define a CMD to start the application, and then we go on from there to build and run the Docker image and expose it on port 3000. So I'm following these 2 steps, step 1 and step 2, to write my Docker file. Let's go back to our code. By the way, I have an Ubuntu instance here. Before we even go to the code, I'll copy my IP address and I'll connect to it via SSH from my local host. My key pair is this, the user is Ubuntu. So we are in the Ubuntu server. By the way, Docker is already installed, and if you want to check whether Docker is running or not, systemctl status Docker. So Docker is already running. So you have a few directories here already. You'll find the code in the Docker NodeJS to do app on the iQuant GitHub repository. If you go to the repository itself, go to the code and copy this link, HTTPS link, and I'm gonna do a git clone. Press enter, and that should download the repository right there. Let's cd into it. Let's see the contents. So we have a Docker file, a readme, package.json, spec, source code, src, and yarn.log. Alright, now our main focus for this part is to build a Docker image. The main thing to look at is a Docker file. Of course, there's a Docker file here, but it's empty. If you cut Docker file, there's nothing in there, so it's empty. So we are going to edit this file to build our application. So to build a basic Docker file for this Node.js application, first define a syntax for your Docker file in version 1. So some keywords, Node 18 Alpine as our base image. You need to specify a work directory. We will call that app. Then we need to copy contents from our local directory into the container, and then we run some shell commands. So yarn install, we call this production. Then you define commands to start our application. Our application is in source code index.js, and then of course we are exposing it on port 3000. So this here is a very simple Docker file, but we don't want to just build any Docker image. We want a Docker image that is lightweight and a Docker image that is built in a very short period. So to optimize this basic Docker file here, I'm going to apply two techniques. One is caching layers and the other one is multi-stage build. And so to do that, instead of just one stage, you see from, only one from command that you see right here, that implies this is a single stage Docker file. I'll create another stage. I'm going to use the Alpine image, and then for the first stage, I'll label it as build stage. When we clone the repository, we had all this stuff in there: spec, src, readme, package.json, yarn.log. Now when you see this copy ... that basically means that copy all of this into our Docker image so that when the container starts running, all these are already copied in there. But to reduce the workload here, some of the things in this directory are not needed at the build stage. So we have a build stage here. We don't need some of them. So the ones that we need is what we are going to copy. So we are not going to copy everything. We will copy just the package.json and yarn.log. And I'm copying it to our current directory. We need this for the build phase, so we need them copied. Everything else can wait till the next stage. And then I'll install the dependencies. And then later, I'll copy the source code into our current directory under source code. I'll do the same for spec into our current directory spec. So that is for the build stage. Next, use 18 Alpine still as a multi-stage image to continue from where we started off in the first stage. And then now I'm going to copy whatever is coming out of the first build stage. So this will be copy from, and the build stage we called it build. This is a name for that stage. I'll copy everything from our app. Remember the working directory is app, to the same app directory on our container. And then we will use node source code index.js and expose it on port 3000. So this is our Docker file. So I forgot one command. When we were building a multi-stage Docker file, normally on the next stage you need to specify your working directory again. Alright, when you save this, alright, so this is our final Docker file. When we build our Docker image, we're going to use docker build -t, and we are calling our app to do app. And then we are building the Docker file inside this current directory. So dot. Okay, so that's successful. Create the screen, do Docker images. You should see our application right there. Now let's run our container using this Docker image. So we're gonna run docker run in detached mode, and we are specifying the port 3000.3000. This is mapping the port 3000 from the local host to port 3000 of the container. Don't forget we are on the EC2 instance. That's our local host. And so for that, you need to make sure that if you go to the security group of our instance, port 3000 is allowed for NodeJS. Okay, and then you give it an image name, calling it to do app, and then you press enter. So it started running. So to see the process, you do docker ps, and this is our container running. Okay, how can you be sure that the container is actually running correctly? You can go back to your EC2 instance, copy your IP address, then paste it in your browser with the port number 3000, and you should see the application come up. Alright, so I'm gonna enter a few things. So it's today's item, tomorrow's item, current item, etc. Okay, you can enter so many things. All right, and that will add it to your application. So application is correctly working. Now, even though this our application is working currently, if I stop my container, this is the container image ID. If I stop it, okay, I've stopped it. So if I refresh this, it's not working anymore. Now let me start it back up by running the container again, because remember, if you do docker ps, see that the container is gone, it's not working anymore. So run the container again, and now it's running. All right, docker ps will show you the container running. So let's refresh our page. See that all the items that we entered earlier are gone. So that's the reason why we are gonna do part 2 for this. We need the data that we enter in here to persist. You want it to be saved in our database, which is MySQL. So I'm just gonna stop this here for the part 1 of this project. So in part 2, we are gonna look at how to persist the data that we input into our application by attaching a MySQL container to our to-do app container. So I'll see you on the next one. Like, comment, and subscribe to my channel for more videos like this. Hello friends, welcome back to my channel. In this video, part 2 of our project about deploying a NodeJS application, we are going to look at how to persist data in our Docker container using a MySQL database. So a few things to take note of. We are going to use a MySQL container. So we will pull a MySQL image from Docker Hub, and then we will run it, which makes it a container at that point. And then to run a MySQL image, you need to set some environment variables like password, username, database name, etc. And then we will look at how to deploy a container network so that the MySQL database container can communicate with our to-do app container. And then of course we will go on to test and verify to be sure that the application is working and that any data that the user inputs into our app is actually being stored by the database. Let's go back to our terminal. So I'm gonna clear this. By the way, if you check docker ps, see that our to-do app container is actually running right now. Before we even import the MySQL database image, we need to create first a container network or a Docker network. And to do that, you use the commands docker network create. Now, if you do this, it will give you the commands to use to run Docker network. You can connect, create, disconnect, etc. Okay, in this case, we are trying to create. So Docker network create. The network, I'm going to call it to-do app network. Docker network ls will list all the networks that you've created. So this is our network we just created, to-do app network, which is a bridge network. Now once you've created that, we are gonna now try to run our MySQL container in detached mode, and then you need to specify the network. You call it to-do app network, and then let's give the network an alias. So let's give it network alias. We call it MySQL. Normally you use the name of the container, which is its host name, as the network alias. And then I'm going to attach a volume, because in Docker you want to attach a volume, use the flag v. Let me break this line and go to the next line. So dash v to do MySQL data, and we are mounting it to var lib MySQL. So it's basically mounting the storage space on your container to the storage space of the MySQL database. Next, we need to specify some environment variables. You use the flag e. To know all this, you just need to look up MySQL, go to Docker Hub. This is the official one. Okay, so this is the image we are trying to pull. To know all the information that I'm typing down there, here are some examples, but we need to specify environment variables. So our command is gonna look more like this. So you specify some name, you attach the volume, and then you specify the environment variables like this. Okay. And there's some more information that you can read on this page. Okay, so you can clearly see there are so many environment variables that you can specify: the password, the host, database, username, and so forth. For our case, currently we you need a root password, which is this one right here. Paste it. Of course, in production environment, you don't want to state your root password in the open like this. So what you would do is rather to do my root password underscore file, using the underscore file, add it to this, and then you give the command a path to where the file is stored. You store the file in /run/secrets, and then if it's a txt file, you state the name of the txt file right there, and this will automatically pick up the contents of that file. But for now, I'll just write the password here as secret. Another environment variable that I need to specify is the database. So I'll copy this. Paste it. And I'll call the database to do app DB. Database. Okay. And of course, we are trying to run a Docker image for MySQL. Okay. We still haven't stated it here, so it's MySQL 8.0. That's the one that we are trying to run. Okay, so when I press enter, what this will do is first look in my local environment if I have this Docker image available already. If it's not there, then it will pull it from Docker Hub. So press enter. Now I already did it in a trial version, so this already exists. Other than that, it would show pull complete. When I do Docker images, you see MySQL 8.0 right here. Okay, let's create a screen. If I do Docker PS, I should now see two containers running, one for our app, one for our database, MySQL. Okay, now that the two containers are running, let's make sure that the database that we created, which is to do DB, is actually created inside our container. And so to do that, I'll go into the interactive terminal of our container MySQL. So I'll use docker exec, then the container ID is this, paste this here, and it's MySQL, that's the name. And the user, I'm going to use root, and this will ask for a password because we provided a password when we run it. Okay, press enter, and the password, remember, is secret. Enter secret, and we are inside the container. So some MySQL commands you can run here. You can run show databases, and these are all the databases that are in there. This is the one that we just created using the docker run command to run the Docker image. Alright, so that shows us our MySQL Docker container is working correctly. Alright, so I'm gonna just get out of this using the keyword exit. Okay, both containers are running, but how do we get the two containers to communicate to each other? How do we get them to actually allow traffic to and fro from each other so that any data that is put in here is saved in the MySQL container? Right? How do we do that? Now that's when networking comes in. Remember, we created a Docker network earlier. We called it to do app network. If I do docker network ls, this is the network we created earlier. But on this network, we need another application that will facilitate the flow of traffic from one container to the other, such that whenever there's anything to troubleshoot or anything to debug, this application will step in to fix everything as far as traffic between the two containers are involved. Okay, now this is a very famous container out there. I'm gonna use this application called NetShoot. And NetShoot is a Docker image that facilitates the flow of traffic between or multiple Docker containers that are running. This is a very good application, by the way. I'm going to install this or run this container as well to facilitate that. And so to run it, you have docker run -it, and I have to specify the network. Our network is called to do app network. And this application that I specified here, the name is Nicolaka NetShoot. So that is exactly the name on the GitHub repo. Press enter. Alright, I already tried this out, so it says it already exists. If not, it would say that it's pulling from each one of these images. Okay, alright. Now let's see how it actually facilitates the communication between two containers. I'm going to use the command dig. Now dig basically fishes for information about each container. So if I wanted information about MySQL, I just do dig MySQL, and that will give you some information about the MySQL container right here on that traffic. So if you look at the answer section, you see MySQL, and you see this right here. It looks like an IP address. This is the IP address that Netshoot assigns to the MySQL container. Once you assign an IP address to a container, you've basically opened up traffic to that container. It will do the same thing for our to-do app and then cause the two of them to communicate with each other. That is just by the way. I'm going to exit out of this. Then I'll clear the screen. Okay. Containers are both running. Let's try to connect the two together. So we can clearly see that our Docker image for MySQL is running currently, but we have several Docker images here. Currently only the database container is running. Let's run our application image. Let's run the container for that, and let's see whether it's able to communicate with MySQL database. Currently, this is our application. If you refresh it, because the application is stopped, there's nothing here. It will not load. So I'm gonna run our Docker image on the network that we created, which is to-do app network, setting the working directory and the volume, and then providing the MySQL environment variables. And then this is our to-do app. That's the name of the image right here. And then we use shell to run a dev environment for container. All right. And then of course we are forwarding ports 3000 on our container to 3000 on our local host. Press enter and the container is started. So docker ps, you see your MySQL container running. You see your application container to do app running as well. So at this point, if you use the IP address and the port number 3000, this should come back up. Okay, so you see more items in here. Okay, when I add some more, this should reflect in our database. So some more and more items. Include an item every minute. Just adding stuff in here. Okay, of course you can delete stuff too. Okay, so when I run docker exec in interactive mode, which is the terminal of the container, and I take my MySQL container ID, and of course the name is MySQL, the user is root, and this should ask for a password, which is the /p, and our database is called to-do app DB. That's how we called it earlier. So I made an error somewhere. Oh, this should be together DB. Right. And remember our password is secret. Press enter. You see that we are in. So show databases. These are all the databases. This is our database. That's the one that we are trying to look into. So some MySQL commands, select star from to-do items. By the way, don't forget to terminate each MySQL command with a semicolon. Okay. So you see that the stuff that we just added, that include an item every minute and stuff, have already been added here. I'm gonna add even some more. Red menu. Let's see. Now when I refresh this or rerun this same command, see red menu is appeared here. Okay, so everything is working correctly. Our data is being persistent. Let's exit. And so I'll end this part here. So far, we've set up a MySQL container, put the image, set our environment variables, password, root user, and database and stuff. And we deployed that container on a network using Netshoot. And we've also verified the deployment in our web browser. You've seen the actual interactive content of our MySQL server. Okay, And on the website also everything is working correctly. Alright, thank you for joining me in this video. Please stick around for part 3, which is the final part of this project. Like, comment, subscribe to my channel, and leave any comments you have in the comment section below. Hi friends, welcome back to my channel. Now in the previous video we talked about how to persist data using MySQL container, and we did a verification of it. And this last and final part of our project, we are looking at how to configure the deployment of the two containers that we created, the container for the app and container for the MySQL server, and how to deploy it using dockercompose. So I have a few steps written in here. First, define services for both containers, the NodeJS app and the MySQL. We already set up a network, so we add it to our dockercompose file, and then we will map our ports and volumes, and then we will start the dockercompose service, and then we will try to verify it at the end. So without wasting much time, let's go back to our terminal. By the way, this is our application. Before we even deploy using dockercompose, stop these two containers that are already running from part 2. So let's use docker stop, then the container ID to stop the container, and then of course we will do same for the MySQL container. Docker ps will reveal that there's no container running currently. Alright, so if you look at our module, you have dockerfile, readme, and other stuff in here. Okay, to create your dockercompose, you're gonna create a file called compose.yaml. So let's ci into it. Currently empty. Okay, alright, now to write our compose file, we need information from when we run the following Docker containers. Okay, this one is the to-do app container. This is a command we use to run it on the terminal, and this is a command we use to run the MySQL container on the terminal. Starting with the to-do, we forward ports from 3000 to 3000. You set your working directory is /app. Set your volume, present working directory, you mount it to app in the container. And then you specify the network that we created. We created a to-do app network, and then you provide some environment variables for MySQL. But here you need to specify your DB that we created. Remember, we created a database to-do app DB. And then our Docker image is to-do app, and then we use shell script to run the Docker image. And then for the MySQL container, same network. We gave it a network alias of the host for the MySQL container, which is MySQL. And then you attach the volume, and then of course our password is secret, and then the database is to-do app DB, which is the same as this right here. And of course we are using MySQL 8.0. So based on this, we will write our dockercompose file. For dockercompose, you need to specify services. Now services is, each one of this is a service. This is a service, this is another service. So we have two services here. Alright, and so our services, we have the app, and then we have MySQL, another one as a service. For the app, our image is to-do app. Paste it there. Command. We are running this shell command. Now watch for the indentation. Okay, it's very important. Now, ports, forwarding the ports 3000 to 3000. Working directory, working _ dir. Of course, our working directory is /app. Volume. By the way, all of this information is right here. This is the port. This is the working directory. The volume is pwd to app. Okay. The present working directory is the same as /. We are mounting it to /app, which is exactly the same as this. And then you need to take care of these environment variables. Okay, so that's for all 4 environment variables, right? So again, the same format. By the way, the volume should be volumes. In Docker Compose, after you specify the services, the last thing we need to define is the volumes. Here it's going to be to do MySQL data. All right, I'm going to get rid of all this stuff. Yeah, this should be like that. Okay. Save this. Now if I cut my compose file, yeah, so our Docker Compose looks like that. Before we run our compose file, just be sure to check Docker PS, there's no containers running. To run both containers at the same time, type Docker Compose app. If you want to run it in detached mode, just give it /d. If you also want to see what is going on, just do Docker Compose app. Service app volumes must be a list. Oh yeah, I made an error here. A list is indicated by the / there. I need to correct that. The volume. Okay, so you need to put a slash in front of it like that. Okay. Display it again. All right. So if you do Docker Compose app, this will start creating your containers. Okay, both of them. Okay. Docker PS. I exited out of it, so I just wanted to show you the output that you could get. So I'm just going to run Docker Compose app command again, this time in detached mode. You can see both containers have started working. Right. Now, when you do Docker PS, you see both containers working. If you like to, you can look at the logs of our Docker Compose. See the Docker Compose logs, -f flag. This basically will follow you through the logs. There's a lot of things going on here, but you can at least see where the connections were going on. It's tried earlier, it didn't work, and then it was able to connect it right here. And so it's connected to MySQL hosts. Since both of them are working, if you refresh this, it's gonna be working. Let's add some items. So red item, green, blue, yellow, arts, songs, and then I'm gonna check MySQL to be sure that all these items that I defined are actually there. So I use docker exec interactive mode, and then MySQL ID is right here. Yeah, that's the ID. Okay, and the name is MySQL. I'm using the user root, and then we'll ask for a password, and we are looking at a database to do app DB. Our password, remember, is secret. I will type it, but you will not see me type it. But when you press enter, you will get in there. Show databases. Remember to terminate each command in there. See, that's our database. To see what's actually in there, use this SQL command select star from to do _items. Terminate it. And you see the items that we entered right here, all of it here. Okay. Okay, let's exit it. I'm gonna try to stop the to do app container. Docker stop that. That stopped. Docker PS, only the MySQL container is running, right? So this will not be working. But if we go back into the MySQL container like we did earlier, the password secret, show databases, select star from to do _items, terminate it. See that all the information we entered earlier is still there. So that our data is persistent, even though our application is not reachable because I've stopped the container. Okay, so that is how you would use Docker Compose to deploy our application successfully. Okay, gonna exit out of this. All right, tear everything down. Use Docker Compose down, and all the applications that you deploy using Docker Compose will go down. You see, they've been removed. All right, so Docker PS will reveal that no container is running. But there is something else I need you to note. Whenever you do Docker Compose down to tear down every container, this does not automatically remove the volumes that are attached. Okay. So if you really want to remove the volumes as well, then you need to add the dash volumes flag, okay, to your Docker Compose down command, just to get rid of the volumes and the containers, everything together. All right. So I'm gonna stop here. Please like, comment, and subscribe to my channel for more project-based DevOps video like this on YouTube. See you in the next one.